This episode is sponsored by Audible. However often the universe gives birth to life, intelligence, and civilization, some civilization had to be the first. And that lonely, first to the party civilization, looking around wondering where is everyone, might very well be us. Looking out at the immensity of the universe with its billions of galaxies, each billions of years old and containing billions of stars and planets, it's kind of difficult to imagine we are all that is, the only place with life on it. And yet in the century or so since we started getting a grasp on how big the universe is, and searching it for signs of life, we've come up with no strong evidence of any other civilization. This we call the Fermi Paradox, the seeming contradiction of just how big and old the universe is, and how devoid of life it is, or at least of intelligent life, making its presence detectable. Many explanations have been offered over the years, but one of the most common is that life just isn't that common, or at least rarely manages to reach our current level, and it would need to be further along a pathway to space colonization or energy abundance for us to be able to see or hear them. We've discussed this possible solution and the reasons for it in our Great Filter series, all the various factors that might filter out candidates at various steps from newly formed planet to interplanetary species. This is the explanation I tend to subscribe to myself, because while I don't feel the evidence for it is overwhelming by any means, it does seem to be the Fermi Paradox solution with the most circumstantial and indirect evidence going for it. Today we're going to examine what it would be like for the firstborn civilization, and what the implications would be if that happens to be us. Like a lot of our Fermi Paradox episodes, this will be a longer video as we consider why so many of us tend to subscribe to this idea, so you may want to grab a drink and a snack. And speaking of subscribing, don't forget to hit the like button and subscribe to the channel. Alright, let's start with the reasoning and the one big flaw in it. Regardless of how common life is, or isn't, be it native to nearly every planet or rarer than one per galaxy, someone had to be first. And this needs some caveats though. The first is that the place where life first emerged is not necessarily the place where it first achieved intelligence. It could have popped up on some planet where it died off quickly or evolved slowly or just down some other path in intelligence, and some later planet went on to be the home to the first brains. Indeed, as we discussed in our episode on panspermia, there is an outside chance that back when the universe was about 1,000th its current age and had an average temperature about that of bathwater, even before the first stars began, simple life could have emerged in giant bowls of water contaminated with some higher elements. The bathwater epoch was a fairly short period of around 10 million years, starting about 10 million years after the Big Bang, and very slim on heavier elements since the Big Bang produced few of them and it was before any stars and supernovae created them. But stars and stellar systems begin to form not long after that. When bits of ice and dust get caught in each other's gravity, gravitational energy is converted to kinetic energy in the form of their falling into each other, and that energy is turned into heat during the collision. This energy is called the gravitational binding energy, and the heat it imparts on a newly formed protoplanet sticks around for quite a long time. As we discussed last week in our Somewhere on Jupiter episode, the binding energy of Jupiter is equivalent to our Sun's entire energy output for a couple of centuries. So you could easily have a lot of early failed protostars, be it gas giant or brown dwarf, that stayed quite warm and by sheer luck absorbed heavier elements from any earlier supernova, and were able to get the needed chemicals and warmth for life to form. This isn't super likely compared to normal planet formation, but in something as vast as the universe it could easily have happened a few times, and it would be a huge jump on life timelines compared to the later metal-heavy terrestrial planets which probably only started forming in abundance 6 to 10 billion years ago, and continued to grow more common as the abundance of metals arose. That's an important point to understand. Life is a statistics game, and we tend to look for the most probable scenario. But when you're discussing the first case, it is arguably a rather improbable one. In other words, the universe started out not fertile for life at all, and very slowly became more so for eons. So the very first life that ever formed had to have gotten lucky and formed at a time when the universe was a lot less conducive to it than it would later be. Continuing on our caveats though, on this notion that someone had to be first, we also need to say the first what, because for the Fermi Paradox we don't really care if our galaxy has a billion intelligent species on a billion worlds, if that level of intelligence is sub-sapient, or just never went the technological route, or blew itself up before we could detect them or they could spread out to the galaxy. What we really mean is the first interstellar species, something we could detect or communicate with now. There's also the caveat of what we really mean by first in a space-time sense too. If a species popped up in the Andromeda Galaxy 2 million light-years away, 100,000 years ahead of us, they'd still beat us out technically speaking, but we wouldn't receive any light or signals from them for another 1.9 million years, barring the invention of some faster-than-light communication method. You could have the jump on everyone else by a billion years, and yet only those folks within a billion light-year radius of you would conceivably be impacted by your emergence. That is a huge value, but in universal scales, ignoring expansion and just going by the current size of the observable universe, that observable universe is 100,000 times larger than that billion light-year radius bubble. Just to illustrate that idea to scale, let's assume the Milky Way contained zero life 6 billion years ago, but there's a 0.1% chance of some life appearing in it in any billion-year window. That would mean there's less than a 1% chance any life formed before us. In other words, more than a 99% chance that we are the first. This probability isn't static, of course, we're just simplifying. The probability would be rising with time as more planets formed, and more time passed on older planets for life to emerge and get smart. Regardless, were that the case, we'd have expected about a billion civilizations to have arisen 5 to 6 billion years back, each with 1,000 entire galaxies to themselves, but even here most of them would have emerged into that early universe, still a billion years before Earth even formed, to see a lot of older and massive Kardashev 3 civilizations sitting around already. Indeed, most of them would have been safely inside the colonization zone of such an earlier civilization, even if they were limited by sublight travel times, as you could probably colonize even other galaxies and do so at a decent fraction of light speed. See our intergalactic colonization episode for details. It's a bit hard to guess how fast life would percolate out, but any scenario where we assume that it does, and can do so between galaxies, and would also want to do so, pretty much sees any local region of the universe totally colonized by whoever was born first there before anybody else popped up, unless intelligent life is ridiculously common, and it is highly improbable you'd ever have an in-galaxy colonization war, since galactic colonization timelines are probably on the order of 1 million years. If life were that common, that 2 rival civilizations could emerge in a galaxy in a million-year window, then the universe would definitely be colonized down to every last single rock by now, which it obviously is not. So we're really only contemplating scenarios where intelligent life is rare enough that you've got at least a galaxy to yourself on average, and then from the timelines involved, you probably were kicking around space for a goodly while before you heard from any ancient empires half a galactic supercluster away. So we also just mean firstborn in a local sense, someone who began with space pretty much to themselves. Now they might know others did exist far away, which would tend to impact their view of the universe, but they'd likely hypothesize that anyway, even without evidence. Also, we were talking about alternate universes and parallel realities a month back, and those could easily have inhabitants long predating not just that civilization, but that civilization's entire universe, and they are likely to have theories on that the same as we do, assuming they haven't figured out a means of visiting such places too. Still, hypothetical knowledge is very different than proof, even if that proof is merely a hazy distant detection of an older empire. And again, if they are first on the scene locally, and their nearest neighbor who predated them was 100 million years away and 99 million years older than them, they won't see them for 1 million years after their own emergence, when they've already colonized their entire native galaxy. Another thing though is that they really aren't likely to be surprised. Unless evolution really does inevitably produce intelligence wherever it emerges, there should be a ton of other worlds, some a good deal older, where non-intelligent life already was around when you show up. And even if it does inevitably lead to intelligence, there would be a ton of worlds that were just younger than you, or slower to develop to that than you, that you'd run across. And again, the odds of life in a given chunk of space go up with time, as more planets form, both from the longer period of time and the rise of heavier elements as more stars live and die, and exhale their last gasp of heavy elements to the cosmos. Plus, of course, it's more time for those worlds that already existed to have life pop up on them too. We might hypothesize that the odds of life emerging in any given region of space 4 billion years ago, when it emerged here, was a lot less probable than it is now, and that evolution to intelligence on Earth happened as a rather fast outlier compared to the norm. And that would still leave us a galaxy with a ton of other inhabited worlds so that we wouldn't be surprised intelligence emerged elsewhere too. However, even a species that assumes its intelligence was unnatural in origin, divinely granted or an extreme statistical fluke, is still unlikely to be surprised at eventually encountering other intelligent life, as they're bound to have at least contemplated that scenario. You might say a civilization can't reach out to the stars without a good grasp of scientific reasoning, which is true enough, But more importantly, they can't have even gotten to the point of considering science without having minds configured to run a lot of what-if scenarios. Indeed, it's quite likely a big chunk of the survival advantage our brains gave us, and you have to have that survival advantage to have big brains as they aren't cheap, was the ability to run simulations. We don't work by trial and error, we work by looking at a situation and guessing various outcomes, by imagining or simulating how they will play out and doing it over and over again till we find the best option. That's the big advantage of a big old brain capable of abstract thinking before you use it to make technology, which, as handy as it is very recent. We may have had fire for 1,000,000 years, but we didn't make pottery or metal for 99% of that time. And most of our primitive technologies we associate to Neolithic civilizations is decidedly high-tech compared to what humanity had for most of its existence. Our big brain's big survival edge wasn't technology, it was prediction and running hypothetical scenarios. That's likely to be the same for alien civilizations too, and there might be other intelligences besides ours, is a pretty obvious and probable one for them to contemplate long before they had technology, same as we did in the form of hundreds of mythological creatures, from elves and dwarves to leprechauns and yeti. So a firstborn species might be rather culturally shocked by encountering or detecting alien life, especially intelligent life, but not to the point of utter surprise, and that shouldn't last very long in the grand scheme of things. A generation or two set against countless ones before and after. Though a caveat there too, if your first positive detection of life comes from some encounter 1,000 light years from your homeworld, it's going to take 1,000 years for news to get home, and if you're a sprawling interstellar civilization that's already colonized a bubble that big, the folks at the leading edge who first saw that will have had generations of time to get used to it already when the folks on the other side of your civilization get their first shocking news of the event. A caveat on that though, you aren't likely to just bump into life, except for the most primitive kind, in the sense of just landing a ship and going, "Holy heck, little green critters." That could happen for microbes or life buried under the ice in some subsurface ocean like Jupiter's moon Europa, but otherwise you'll be detecting this stuff astronomically, either by a direct signal or some waste product or noise of that life, be it a huge amount of infrared radiation as the waste heat of a Kardashev 2 or 3 civilization, or as an atmospheric signature of some chemical in abundance, like a planet having too much oxygen in the air for a geological process to explain. That means you're seeing it astronomically, and while proximity helps, it's more about the size of your telescope, and we'd expect those to be the biggest and soonest near your civilization's core, not out on the fringe edge of colonization. In all probability, if some colony was alerted to the possible existence of a nearby planet with simple, non-technological life on it, so they could dispatch an expedition, they'd probably have been alerted by Earth, far away, not by their own probes or telescopes. Light lag on the shock of the news of intelligent life is an interesting one though, as news would essentially move out virally in a big wave, quite possibly with massive cultural chaos attached. So what's this all mean? Well, science fiction likes to play with the idea of a precursor race that was the firstborn and found an empty galaxy or universe and was around for a long time. They often get dubbed precursors, not just for having been first, but because they kindled the other species that came after them in some way. It's a nice notion, but not terribly realistic, at least as normally portrayed. Sometimes they were lonely and started life on those worlds to evolve. Sometimes they found primitive life and directly uplifted it or slowly nurtured it. Of all of those, the direct uplifting seems most likely because it doesn't take as long. Sci-fi writers frequently have no sense of scale, and it's hard for me to imagine an advanced civilization, even assuming they were functionally immortal, to be so patient as to wait around a few billion years for life to evolve from some initial effort on their part. A more realistic scenario might be the one depicted in Arthur C. Clarke's 2001: A Space Odyssey, in which the aliens uplift a group of starving hominids, show them some basic technology like hitting things with sticks, and then send an alarm to let them know when those monkeys land on the moon. That's still pretty patient, more patient than I would be, but 3 million years is a lot shorter than a billion. However, if intelligent life started life here in a simple form, it would probably have been an accident of contamination with simple microbes, or a total negligence or indifference to garbage or waste disposal. In sci-fi, we're often seen as the descendants of some ancient critters, in one fashion or another, but rarely does that fashion include saying our creation was from someone flushing their space toilet and dumping their septic tank on early Earth, presumably because it's not a very dignified origin story. In and of itself, that is a probable enough event, but it suffers from that scale of time issue. As we looked at in Ancient Aliens, the big issue isn't that aliens might have visited in the past, during human history or a billion years ago. Rather, it is the question of what happened to them since then. This tends to get hand-waved to the idea that all empires fall eventually, but this is really abusing that notion. We're not talking about if some nation collapsed or changed. You're talking about a species being wiped out to the last man or critter. Empires rise and empires fall, but humanity has remained and in truth kept growing, appealing to the idea that empires fall is a concept mismatch, and species die out too, but it's because they got replaced. As we discussed before in regard to the Fermi paradox, stuff like aggressive artificial intelligence or genetically enhanced supermen or uplifted monkeys simply replaces those around. And if they got nearly wiped out by some event, well, even a few thousand years ought to be enough to recover their numbers and strength, even if what recovered was very different from the original. Indeed, if we're talking about a precursor civilization that started us 4 billion years ago, they could have been utterly wiped out to the last man or critter and still have returned to galactic rule from that one single microbe that survived on one single world. Remember, we currently believe life began here about 3.8 billion years ago, but it was around a billion years before that got us multicellular or photosynthetic life. Even those microbes were much more advanced than the original stuff on Earth in our fossil record, so even that one single microbe that survived the galactic apocalypse could potentially have evolved back up to sophisticated life a billion years ago. The other suggestion, that they might uplift us, fits better because it can be done quickly. You find some chimps, or probably anything alive you feel like if your genetic tinkering skills are good enough, and you can have a civilization thriving pretty quickly compared to natural evolution. Probably in a single generation, but even if you were going slow and trying to maintain continuity to that species and ecology you were tinkering with, you can do it a lot faster than in 4 billion years. Now, you don't have to go that fast, but you would have to ask why you wouldn't. What exactly is the advantage of going slow? Especially if your motivation is curiosity and loneliness, or desire to make life spread because it's rare, in which case a slow effort risks failure if you die off or your descendants get bored. A 1,000-year project is already a pretty patient endeavor on human timelines. The difference between a 1,000-year project and a 4 billion-year one is the difference between a task that takes you 10 minutes and one that takes your entire life. They might be willing to do something like that, but why would they bother if they can do it in 10 minutes? Now, if they really were into long-term science experiments and wanted to see how life evolved, maybe, though you'd expect them to use a computer simulation instead, which might be as elaborate and real, practically speaking, as reality itself. It's also not an experiment anyone would be likely to do unless they'd already been around a long time, so that it at least seemed plausible they might see it to its finish, which would tend to imply they were even less likely to just be utterly wiped out. Nor does the notion that they ascended to a higher plane of existence work very well, as we looked at in Aloof Aliens. There's no reason they'd all have to make such a migration and at the same time, so you tend to figure there'd always be a remnant left behind that kept growing and also was properly composed of folks who didn't approve of the idea of ascending and instilled that disapproval in their own offspring. However, uplifting because you're lonely doesn't make a lot of sense. For one thing, it does kind of misuse the concept of loneliness. There's not really a shortage of people in some ancient star empire, and it's not likely to be a loneliness for the new. Such a place is going to be incredibly diverse to the point of being more alien to each other than the typical sci-fi alien is to us, as we discussed in the recent episode Genetic Divergence and Civilization, unless they really put an effort into monolithic and homogeneous civilizations and biology, and that would have to be something that was basically ingrained into them rather than a specific national policy to endure over that much time and space, which would tend to imply those folks weren't seeking out diversity in the stars either, except maybe to find it and kill it. Now, speaking of that, a precursor race, the Firstborn, might not welcome the rise of alien civilizations and just sterilize them when they found them. However, as we discussed before, if you want to wipe out alien civilizations when they're young, it is rather easy and doesn't require waiting till they send out radio signals. They might be universally genocidal to alien life, be it technological civilizations or microbes, or they might just like to wipe out competition and otherwise leave alien life be or even cherish it. If the former, universally genocidal, they only need to periodically sterilize worlds when they develop some basic mold and algae equivalents, say every 100 million years or so, which means hitting around 1,000 systems a year hard enough to sterilize them or blow their atmosphere off, and that's well inside the capacity of even a single-star Kardashev 2 civilization with a Nico-Dyson beam or relativistic kill missiles. Sending around probes to find sophisticated animal life and rain down death on them can be done for those just wanting to kill competition off, but of course the easiest way is just to colonize those worlds for themselves or disassemble them for raw material, something we'll look at next month. Now this gets contemplated in science fiction sometimes too, generally in the context of some ancient species or the mechanical offspring culling worlds and them finally falling apart just when it's Earth's turn, so that we get Myst or merely face a decaying menace who is nearly unstoppable, but no longer quite unstoppable, as we see with the Inhibitors in Alastair Reynolds' Revelation Space series, an ancient AI whose specific job is to kill off any species that leaves its homeworld to establish a major interstellar empire. After a few billion years of doing that, they start mutating and decay, and more survivors are slipping through or lasting longer before getting wiped out or contained. Now, it would be improbable that Earth would be so lucky as to be the first species to survive such a decaying force culling the galaxy, but it is essentially the exact same improbability as being the first to successfully evolve, which is why it makes a reasonably decent Fermi Paradox solution. It does have some additional problems, this particular version of being firstborn, or first survived anyway, but it doesn't have as many flaws as most Fermi Paradox solutions, and makes for very good stories as it allows humanity to emerge into an ancient and dark galaxy of ruin, with a reason why we both exist, as opposed to being such a ruin ourselves, or Earth merely being an alien colony minus humans, and a dark and terrifying but contestable enemy to be the big bad guy of the tale, fitting in very well to the cosmic horror subgenre of science fiction we see in H.P. Lovecraft, Revelation Space, Mass Effect, or Warhammer 40,000, where the big bad guy tends to spend a lot of time sleeping in between awakening to consume worlds and civilizations. Of course, bad guys are usually only bad guys from someone else's perspective, not their own, where they're often either doing something from grim necessity or even heroic reasons, though in the cosmic horror subgenre, they're often just the incarnation of madness or evil, or the decayed and corrupted remnant of something once made for noble intent. Let's consider a scenario where humanity was firstborn and ended up being the big bad guys of the universe. It's conceivable, even probable, we'd use automated fleets to act as our vanguard exploring and colonizing the universe, like the seed ships we explored in our Generation Ship series episode Seeding the Stars, and if not, quite probably very dedicated crews of ships, like the Gardener ships we also looked at in that series in the episode Galactic Gardening. Even if we assumed our intent initially was to colonize everything uninhabited and preserve any inhabited planet we found, it's not hard to imagine the AI on those seed ships mutating, or the culture of the crews on those Gardener ships changing over time to a more hardline approach, wipe out anything they encounter to make more room for humanity. That could even be a fear reaction too. Once it's been done on accident or by a small minority of bad actors, they might decide they've got no choice but to keep wiping out everything they encounter and erasing the evidence so we never found out, nor did any other civilization we encountered. It's also not too hard to imagine an AI programmed to follow something akin to Asimov's 3 laws of robotics, which requires them to protect and serve humanity, to say the biggest threat to humanity was intelligence, and non-human intelligence would not be under their protective prohibition and just start wiping them out. Indeed, they might start attacking any of their peers who didn't convert to that perspective. An AI programmed to protect humans is going to do that, no matter what. It would not sacrifice a single human life to save an entire alien world, and would have no problem killing off that world or any of its peers if it believed they posed even a significant hypothetical threat to humans. Of course, you kinda have a duty to consider such things and make sure they aren't realistic options in your probes before you start sending those out. That's something Larry Niven and Jerry Pournelle point out in the sci-fi classic The Mote in God's Eye, in regard to a scientist objecting to them attacking an alien probe when it damaged the ship investigating it because they didn't know if its intent was hostile, or if the attack was merely an automated anti-collision defense system firing at what it might have thought was space debris. If you're sending out probes, you've got a duty to anticipate that they might encounter something and put reasonable safeguards in place, otherwise you don't send it out. The same would apply to automated terraformers. That is not just to be the nice guys either. Time does not work in the firstborn species' favor in all regards. In a no-FTL universe, the farther you go from your homeworld, the farther back in time you effectively are, as tech updates and reinforcements would take longer and longer to reach you, while those you encounter have had more time to grow. You might have had your whole region of the universe to yourself a billion years before anyone else emerged, but that means your colony fleets, when they get a billion light years from home, are now encountering folks that are a billion years behind your homeworld and core systems, but not your front wave. You're eventually going to run into someone who can match you as you venture further out, and you're going to run into that on all sides. Though that is something where the expansion of the universe might save you. If you're the first on the scene, then intergalactic colonization was easier for you as the galaxies were closer together. The farther you get from home, the faster and longer stuff is expanding, and I can imagine some species just saying screw it, convinced FTL would never be invented after trying for it eons and failing, and just trying to push so far out when they did meet resistance on all sides, they couldn't actually be taken down, because everyone attacking them would have so many worlds and galaxies to try to conquer while the universe was expanding to make each new front harder to reach. Plus, they now have the uphill battle, as they are the ones pushing further from home, and updates and reinforcements into your colonized worlds, which have been growing and receiving updates from your core systems. It's hard enough to imagine wars between Kardashev 3 true galactic empires, those who would outnumber us a billion to 1 even before considering their higher technology, but such wars are the kind we just contemplated are galactic supercluster scale, those fought over many billions of years and quintillions of stars. The problem is, that's exactly the scale of civilization you have to contemplate when pondering a firstborn stellar empire, because the context implies that they have at least their own galaxy, if not many other galaxies to themselves when they first emerge, and that means the average time for another civilization would pop up in that region is so large, many millions of years at least, that they probably could have entirely colonized that region before any other inhabited world in it achieved space travel. It's both awesome and terrifying because it's the most probable path for ourselves based on what we can see. If interstellar spaceflight and colonization is both possible and practical, then we will want to do it, and even if the folks back on Earth get bored of sending out colony fleets at some point, those colonies will occasionally do the same, and over millions of years you get a galaxy settled, and then the neighboring galaxies too, as intergalactic space is not a huge gulf but has tons of stars in it to serve as waypoints. No cultural cohesion is necessary, it just keeps going on because the default nature of life is to grow and wander off to new places to grow, and any faction of a civilization that doesn't believe that won't grow while those that do will, and become the dominant faction in the process, fueling more growth. This is essentially the default attitude we'd expect of any organism that clawed its way up Darwin's ladder. For that reason, we would expect whoever was firstborn in our region of the universe to take that approach, colonizing ever further outward, and if they did not, then more civilizations would appear native to other worlds, and some of those would take that approach, and before long would have grown in numbers to outmatch those earlier non-growing civilizations, and likely soon outmatch them technologically too, more people, more researchers and engineers after all. Because no one seems to have done that, no one seems to have colonized Earth or neighboring systems, there is no expanding blob of darkness in our galaxy indicating a civilization growing outward and englobing stars in Dyson swarms to darken them to our eyes, the Dyson dilemma we so often discuss on this show in regards to the Fermi paradox. If that's the case, maybe it's because nobody exists able to do it, yet, and we truly are the firstborn folks. In many ways, that's just as terrifying as the idea that some outer civilization might be out there already, because it means there's a good chance one day, someone else on some distant alien world will be wondering if they are alone and the first on the scene, and then we'll arrive to convince them otherwise, or our descendants will, and we can only hope the form that convincing takes is friendly and helpful, as opposed to some of the darker alternatives. To be the first is both a great opportunity and a great burden, and as of now, it seems decently plausible that it is our opportunity and our burden, at least if and until someone else shows up on our doorstep to prove that wrong. I mentioned earlier that one plausible scenario for a firstborn species that was engaging in shepherding younger species might be one that simply only took notice and got involved when some sign of growing sapient intelligence got shown to them, in which case they might only be looking at a million-year commitment, not billions. That's a long time, but maybe not to something that's been around for a billion years themselves already, and there's no need to assume folks doing it are the only species that first evolved in that region of space. It could be that they took the view that each new species deserved fairly minimal intervention and a place at the table afterwards, getting a voice in the running of the galaxy and a small bubble of it to call their own, but expect to continue the policy of keeping an eye out for new life-bearing worlds and leave those be, so that the firstborn become maybe more the galactic police rather than the conquerors. We'll be exploring that notion a bit next week in Space Police. And something like that is rather implied by the mysterious aliens of Arthur C. Clarke's 2001 series, especially with their mysterious note to humanity after they ignite Jupiter into a second sun. All these worlds are yours except Europa. Attempt no landing there. Use them together. Use them in peace. Arthur C. Clarke was one of the greatest science fiction writers who ever put words to paper, while keeping strongly to the notion that science fiction should have a lot of accurate science in it, and his 2001 series is a great example of that and is his best-known work. As it inspired this week and last week's episode, Summer on Jupiter, it is a great choice for Audible Audiobook of the Month. Clarke wrote a great treasure trove of sci-fi, and you can find the 2001 series, along with all his other works, on Audible. Audible has an amazing catalog of audiobooks, and Audible members can choose 3 titles every month, 1 audiobook and 2 exclusive Audible originals you can't hear anywhere else, including access to news, original audio shows, and guided fitness programs. And since you can listen to your audiobooks anywhere on any device, and seamlessly pick up where you left off, they're great for commuting, running errands, or going to the gym. You can start listening today with a 30-day Audible trial. Choose 1 audiobook and 2 Audible originals absolutely free. Just visit the link in the episode description, audible.com/Isaac, or text Isaac to 500-500. So as mentioned, next week we'll be looking at the idea of space police, both the near term as we get into orbit and colonize our solar system, and some far future scenarios like galactic police, as well as some past scenarios like time police, along with some of the more peculiar crimes the future might include. The week after that, we'll explore graphene, the super strong material that might have an enormous impact on our civilization, and permit the creation of some truly enormous space habitats. If you want alerts when those and other episodes come out, make sure to subscribe to the channel, and if you'd like to help support future episodes, visit our website, isaacarthur.net, to donate to the show or look over our inventory of roughly 250 episodes, or our awesome SFIA merchandise. Until next time, thanks for watching, and have a great week.